Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode 2563. Count the number of fair pairs. This problem has been asked in companies like Google, Amazon, Bloomberg, Salesforce, and it is based out of the concept of two pointers and binary search. Marked as medium, but I am going to make it easy for you. Let's have a look on the problem statement. Given a zero indexed integer array nums of size n and two integer lower and upper. Return the number of fair pairs. Number of fair pairs in the form of integer we have to return, and this is the definition of fair pair. Any pair, like two different indices, we have to pick from the array, and the sum of the values at those two indices should lie between this range, greater than equal to the lower and less than equal to upper. So this is the definition of a fair pair, and we just have to return the count of all the fair pairs. If I show you the example, so this is the given array to us, and apart from this array, these two integer variables are also given, lower value and upper value, and what I have to return is number of fair pairs from this array. And what is the definition of fair pair? Again, I'm going to show you that if sum of values at those two indices is lying between this range, lower and upper, greater than equal to lower and less than equal to upper, both inclusively, then this pair is considered as a fair pair and going to contribute 1 to the answer. So this is our problem statement, and here I'm going to have a look on some prerequisite problems to make it easy for you. If I just try to simplify this problem, and instead of this range I am taking a single value. See here, the sum of these two values should lie between this range. To make it very simple, it can be equal to a specific target or value. So if I just make it like this problem statement, index I plus index j, value at index I, value at index j is equal to value, just return me the count of those pairs or return me those pairs. This problem will be reduced to #1, problem ID 1 on LeetCode, which is called toSum. The toSum is the problem where we have to figure out a pair whose sum is equal to a specific target. So this is the problem. If I just reduce this range to a specific value. Now this you must be aware. If in case you are not aware with this problem, I recommend you go and watch this video. I will attach in the description below. And to this very reduced problem, very simplified problem, I just have a look on the second variant. It can be something like this. In this case, it is a range that greater than equal to lower and less than equal to upper. If I just simplify it and cut it like 50%, it will be something like two values whose sum is less than a specific value. And this problem is a problem which is a prerequisite to this on LeetCode, which is 2824. And this problem 2824 is count pairs whose sum is less than target. So this is the reduced problem. If we are solving this problem, we will be able to easily solve this given problem as well. Now let's have a look on this easy problem. That given an array of length n and an integer target, return the number of pairs ij such that sum of those two values is less than target. So this is something we have to do, and it's a pretty standard two pointers problem, and we will see how we are going to use two pointers. Let's say from this nums array we have to pick pairs whose value is equal to target, and assume that we have already picked two values I and j, and sum of those two values is less than target. It means that is a valid pair, but this is less than, not equal to. So in this case we might have to end up checking all the different possibilities of I and j. To avoid that, what I can do is, let's say I have fixed the value of I. And now to get every single pair we need to know all the values of j which are less than equal to the current value of j, or maybe some bigger values. Let's say I have chosen the biggest value of j. biggest value of j I could have I have chosen that. If I have chosen the biggest value of j, it means every other possibility of j less than that bigger value. Let's say any item at this, if somehow we'll be able to figure out every single value in a constant time, that is going to reduce our time from quadratic to linear. Otherwise we will end up checking all the possibilities. First loop for I, second loop for j. But we are avoiding that n square time. Why? Because in the constraints the length is going till 10 to the power 5. And if we do the n square, it will go around 10 to the power 10, which is going to give us TLE for sure. So here, if I am fixing I need to get all the values of j which is less than the biggest valid value. In this case, if let's say this is the biggest value, this is second biggest, third biggest, fourth biggest, and smaller ones. If the biggest is going to give me the value that is less than target, so if I just reduce the value of j, that is also going to give me the valid pair. It means if these values are in sorted, we'll be able to utilize that sorted array. So here, let's try to sort this array. -1, 1. If I just sort it, -1, 1, and then again 1, 2, 3. In this case, my target value is 2. So here, if I let's say pick this for I, if I'm picking this for I and I'm considering this for j, if I take a sum of these two values, sum of these two values are equal to 2, which is not less than 2. If it is not less than 2, it means we have to reduce the value. And similar to the two-pointer approach, if the pair we have to reduce, we just reduce the bigger one. So we'll just decrement the value of j by 1. Now if I check the value 2n minus 1, 2n minus 1 is going to give me 1, which is less than 2. See, this is the biggest value of j that is going to give me the valid answer. And this is the value of I. Let's say I is fixed and j value we have found out, the biggest one. So if this j value is working fine, giving the valid pair, then these smaller value will definitely be going to give me the valid pair, right? So starting from I plus 1, all the value till j going to give me the valid pair. What I'm trying to say is that starting from j, this one and this one, all three values are going to give me the valid pair, right? Because if I reduce this value, it will always be less than target. So here what I can do is I can directly pick all the values, all the valid values of j. So those are going to give me unique pair. So directly do j minus I, right? Why? Because I plus 1 till j. Starting from I plus 1 till j, I am going to get the valid values of j. So j minus I plus 1 plus 1. These are the valid numbers. And if I just simplify it, I will get j minus I. So just capture all of these values. If you have captured all of these values, then increment I. Incrementing I to figure out next set of pairs. So capture it and then increment it. But if in case it is not valid, then decrement j. So now we got our idea for two-pointer approach, that if I am getting a valid pair, I will be getting pair if we just reduce the window, check all the valid values of j. If I don't have a valid pair, it means we have to reduce the bigger portion. So if I write the code for this, the left value we can take 0 and the right value we can take n minus 1. And what is the standard template for two pointers? While left is less than r, because we are picking two values, left and right, both are different, not going to equal those. Here I need to get the sum. Sum is value at left plus value at right. Now we have two conditions. If the sum is less than target, if it is less than target, it means I'm going to capture my result. So here it is showing that starting from I till j, if I pick any of the j, that is valid. So answer plus equal to j minus I. This is something I'm going to capture. All the possible answer having I equal to this one, fixed I. And now as we have captured all the answers for this I can comfortably, confidently increment I plus plus. Otherwise, what I have to do is not I plus plus, it is left plus plus and the right minus minus. Don't get confused with this left right ij. So if I just make it clear, right minus left. So this is going to be my code for this easier approach. It means it is going to give me all the pairs whose sum is less than target, less than a specific target. Why? Because I'm going to capture it for every possible value of I. And what is the time complexity of this approach? See, to apply this two-pointer approach, the array should be sorted. So firstly, I did the sorting and then I implemented this approach. So for sorting, it is going to take n log n time, and for two-pointer approach, it is going to take order of n time. That is just adding that, and this is the bigger portion. So this is the overall time complexity for this approach for dependent problem. And in this dependent problem, the value was something like I plus j should be less than value, but our problem is I plus j should be greater than equal to lower and less than equal to upper. Now how do I reduce this value with the code, where the code is something like I plus j is less than a specific value? So this code is done with this way, and this is something dependent on two parameters, lower and upper. So we have to reduce those two parameters to single one. And single one, what I can do is, if I just do something like this, if the value at I plus value at j is less than lower, so if all the pairs satisfying this condition, do I have to consider that in the answer? No. So they are not useful for me. Okay, this one is checked, and now let's have a look on this one. See, less than equal to upper. Can I write it something like this? Less than upper plus 1. The next value to upper is always upper plus 1 because all are integers. So I can write it like this, and this is the same. Upper plus 1 is the target here. So I value at I plus value at j is less than upper plus 1. See, this is the same problem statement that I just did. Pick a pair such that value of those two indices is less than a target. Less than target. So this is the problem that we just solved as a part of prerequisite 2824. And this is the code for this. Sort it and apply the two-pointer logic. So this is something we have done, and if we are doing it, I am going to get all the pairs where the target sum is less than target. It means it is going to have every single pair, including this pair plus our desired pairs. But I want only our desired pairs. So this is the value A and this is value B. So B plus desired pairs is equal to A, and we can easily get our desired pair, A minus B. So what is A? A is sum of all the pairs whose value is less than upper plus 1, and B is sum of all the pairs whose value is less than lower. So we can utilize the same function 2 times and we will get our answer. And similar to above prerequisite problem, the time and space complexity of this approach is firstly sorting it, order of n log n, and then applying the two-pointer approach. First one for this, second one for this, order of 2 into n. Order of 2 into n. So overall the time complexity is order of n, log n. What about the space complexity? Space complexity will be log of n because we are sorting this array. Here this problem is solved using two pointers approach. This problem can also be solved using binary search. A standard vanilla binary search template we can use over here to figure out the range. See, if I just sort the array and for any value of I can easily get my j within the range. For the range, just finding the first position, last position, that range I can figure out. Finding left bound using log n in the binary search, right bound with the log n in binary search. So this approach I have not discussed in this video, and do let me know if in case you want the video on that as well. Otherwise we'll have a discussion in the Discord community, and do let me know what approach you have used to solve this problem. I hope you understood this two pointer method, because this two pointer is also covering the prerequisite. So do submit all of these problems, this one and our problem for today's LeetCode challenge. And in case you are getting started and you want a beginner friendly problem, you can do check out this LeetCode problem ID 127. Thank you guys. Let's write the code for this approach. And here first of all I'm going to sort this array, arrays.sort nums. Now we'll be applying our two pointer approach that we discussed. Helper function is going to give me all the pairs, all the number of all the pairs where the value is less than upper plus 1, and value in the nums array which is less than the upper plus 1 minus, it is going to give me all the pairs where the value is also lower than the lower, but we don't require that. So helper in the nums, I want to decrement all the pair where the value is less than lower. Now this is going to give me all the valid pair in the range of lower to upper, both inclusively. Now let's write this helper function. Private integer helper integer array nums integer target. So integer array nums target, and these two values are going to be a long value. So let's take a long variable here. Now we are going to apply the two pointer approach. Int l is equal to 0, r equal to nums.length minus 1, nums.length minus 1, and I will be running a loop while left is less than r. And here I will just calculate the sum, and let's say what is the value range. Value range is like this, so I can use integer here. Integer sum is nums of I plus nums of L plus nums of R. So this is the sum. If this sum is less than the target, it means every single value of R I need to capture for a particular L, and that is answer plus equal to R minus L. If that is picked for the particular value of L, I'm going to increment L. I require another variable. Long answer is equal to 0 L. So this is the case. Otherwise, if this value is greater than or equal to the target, just reduce the bigger one, R minus minus L plus plus, and now this is the two pointer logic. It is done, and in the end directly return answer. Let's run over sample test cases. On the sample test cases it is working fine. I'm submitting the problem. It got submitted successfully and beats 100% of the Java solution. Thank you guys. Bye bye. In case you get any doubt, you can comment down below.